It's hard to ship heat. It's easy to ship data. We can take the data out of these data centers and we can put it in somebody's house. We can put it in a business. We can replace a boiler with it. If we can boil water, we need to put the heat where there's a need for heat. There's a new way to think about this. All this energy that we use to light up our cities. It's called Exergy. Follow me. I'm going to tell you about it.
I admire people that are driven the way that my brother is. It's the je ne sais quoi, the something that you can't describe that keeps him moving and forcing his way through life each day, and you know, trying to educate people and motivate people to get on board with this idea of changing the world that we live in. We are really kind of crossing into a place on this planet that is unexplored territory for humans. We're making changes to the environment around us that we're not going to be able to reverse. He's kind of like he's kind of Captain Insano as far as like his ideas, and I mean he's his character. He's straight as an arrow, you know. I mean he's a very true person. You know, there's no room for hidden motives. He's living what he means. My brother expects to make a difference in the world each day when he wakes up. And I know that there was a moment in his life where he decided that was the way that he was going to live. When you get down to it, that's really the idea, is that, you know, each one of us could do more.
The interesting thing about Exergy and about this machine, it's really, you know, when you think about it, this box of computer components, all those computer bits in there, they're really just little heaters. They're all really just resistance heaters. The amount of energy that gets consumed by these things doing actual computation, it's so small it can't be measured. And if it could be measured, somebody better tell me soon.
You know, what we're developing here, it would be 1 unit of energy would yield 1 unit of heat and 1 unit of computational value.
It's not going to produce something that's not already being done in the market. You know, there's already, you know, home heating that occurs on a regular basis using various different means. So you're not creating a new product. You're talking about a new concept, a new way of doing things, a way of getting more out than you're putting in right now.
It boggles my mind that we consume as much energy as we do, and then we take that energy and we just pump it to the atmosphere, or we stick it in the ground, or we dump it in the ocean. That's wholly unnecessary. You take that energy and you put the heat where you need the heat. You use it as much as you possibly can. You don't get rid of it. You don't dump it in the atmosphere. That's insanity.
Instead of just having a huge power plant, burning natural gas, burning coal, and generating electricity that then being transmitted to the buildings, how about a scenario where we do the power generation on site? You gain the benefit that it's creating, in this case, you know, the computation power from the computers or energy from solar PV, and you consume it on site. And along the way, you've eliminated all the loss associated with generating it somewhere remotely and then having to transmit that information or that energy back to where the consumption actually happens.
So how have we gotten to this point? You know, I look back maybe a year ago, a few months ago, talking on the phone with my brother about this concept of what he thinks he can do, where he thinks this project, which to me is basically a hobby that he works on, because he's in the renewable energy industry and he's always looking for ways to squeeze more out of a building to put in a more energy efficient light bulb. So in my mind, it's a bit of a hobby, because he's always thinking of these things and looking for ways to do things differently outside of the box. And so we banter on email back and forth about what could and couldn't be. You know, is it really possible to tune a video card such that it would create enough heat to heat a house, to heat a pool, to heat, you know, what things could it heat? What is possible? And so as we go through Facebook, bantering back and forth, he has an appointment, and he comes to visit in Austin, Texas. And so he stays with me for a weekend, and he comes in, and the first night he says, you know what, let's build a computer tomorrow. And so we get up the next day, and we go and we just go to the local parts, you know, computer parts store, and we grab a few video cards, we grab a motherboard, and just all regular components with the intent of putting together another, you know, what will become a prototype. And so he spends the weekend talking to me about, you know, showing me as we're building this project together how we can extract heat from this thing. And so you transition from a concept of it being a hobby to, you know, suddenly it's real. It's in your living room, and it's creating heat right now.
Computation is what makes modern life happen. We use it to learn, to perform work. We use it to entertain ourselves. Think about how often you download and upload pictures, stream videos, or just use Google Maps to get places. Computation is the magic that keeps the world connected and make us more productive. Much of the computation to support our digital life right now happen remotely at data centers. Data centers are buildings that houses thousands of computers, and they consume a lot of electricity. Just imagine how much data processing and storage functions are needed to support our digital lifestyles. Data centers right now consume 2 to 3% of all electricity produced in the US, and that figure is only growing rapidly with our increasing needs for data. Almost all the electricity computer uses becomes heat. And to keep the computer running smoothly, we have to use even more electricity just to keep them cool, pumping the waste heat into the atmosphere. And in the 21st century, this is inefficient.
The actual work required for the CPU to compute is actually very small. It's only like 2 to 3% of the energy used to power the computer is used for calculation. All the rest goes to heat. So it's a whole lot of waste of energy if we just let the heat go into the air and without capturing it and reuse it. And like I mentioned before, 20 years ago we might not have the right technology to do it, but now we actually have all the technologies we need to achieve the purpose.
If we look at kind of the ethos of Bitcoin, and that's essentially distributed, decentralized, cryptographically secure peer-to-peer networks, essentially removing the middleman. And I think when we apply that ethos to, like, let's say environmental sciences, the energy sector, it's very, very easy to see why we have tremendous inefficiency in the energy sector by virtue of sort of antiquated legacy, centralized legacy systems. When we introduce a project like Exergy to the marketplace, I think we have the same kind of net effect that Bitcoin has had in the financial space, which is this tendency towards decentralization, to distribution, to peer-to-peer, to essentially breaking inefficient legacy systems that make it very difficult for us to advance further. We empower people by making their appliances smarter and essentially affording them not only savings but an opportunity to engage in a whole new kind of asset class. And so that appeals to a lot of the Bitcoin community because Bitcoin people get that. They understand what peer-to-peer, decentralized, distributed networks mean, and how decentrist kind of thinking has the potential to really revolutionize the world, really. So it only stands to reason that the most kind of pressing concern we have, which is energy, I mean, this is an existential issue, it only stands to reason that it moves in that direction, because, antiquated legacy systems simply are not going to avail the type of innovation that we need to kind of like survive and thrive, you know, in a sort of scarcity economy.
One way of looking at it is that traditionally we run a computer, and the waste product of that computer is heat, and the product you're trying to produce is computation. The product we're trying to produce is heat, and the waste product of this process is computation. And computation is a very useful waste product because there's always math problems that are going to need to be solved.
This is the way the majority of electricity is made today. Smokestacks, transformers, electricity crackling on the lines. Only a fraction of the energy that we take out of the ground, the natural resource, the coal, the natural gas that we burn in power plants, is turned into electricity. Then we take that fraction and we ship it for miles across power lines to your house to make light, to make heat, to run your television. By the time it gets there, only about 30% of the energy that we pulled out of the ground is useful to you. We've reached a point where we can do things differently, where we can generate electricity right where we need it, right in your home. So we don't have to ship electricity across the lines, use century-old, antiquated equipment like this. We can make the power where we need it and use the heat when we need it. That's what Project Exergy is all about. We want to change the way you think about using energy. Not using less of it, but getting more out of the energy that we're using every day, the resource we take out of the ground. The utilities have kept the lights on for 100 years. There's a new way to do things. Let's get started.
Oh, okay, so what we're doing is we're modifying this RV refrigerator. And we're using it to prove that you can actually cool with the heat that you made. And most people don't understand that you have to have heat to generate cold. If you can make heat, then that's great for the winter. But in the summer, when it's 95 degrees, who needs that, right? What are you going to do with the waste heat? So you need to make the cool. I mean, everybody cares more about the cool than the hot, you know. I mean, you can always put on another layer of clothes. Oh, I almost killed you.
What I'm hoping is that we are able to get the funding necessary to bring a proof of concept to market.
Guys are in Raleigh ready to test them whenever we're ready. We just need to send them over there and get it to them.
Okay.
We can get 210 degrees worth of heat out of the thing. We can plug it into the DVAP and they'll start testing the DVAP prototype against it. We'll be able to make air conditioning.
Who's our software developer?
You know, I want to make sure that we're using an open source platform for the thing. So I've been thinking about some guys with OpenStack or basically some Linux developers. They can work on open source code for the software. I don't want proprietary software in the thing. I want it open source code so people can see how it works and be able to build and adapt on the platform itself.
It'd be a heck of a system to stream video over if you wanted to do that, or just a home entertainment system in general.
It seems like the future is getting away from cable companies and moving towards streaming video and things like that. And the interactions we're going to have are not going to be coming over cable lines much longer. So I can't imagine. That's going to be the cool part of getting the community together is there are people that can think of things that we're not even going to dream of to do with this thing. We just need to be conscious about the platform that we're building for them to do that. We really care about stacking up the benefits of the energy, the heat, the computation, the cooling we can do with this thing, and other people need to figure out what the heck else it's going to do.
You're talking about a new concept, a new way of doing things, a way of getting more out than you're putting in right now. And so it's more of an idea, and to sell an idea you have to convince people, and social media seems to be the best means right now to reach out to people, and from their living room they can take a look at a video and understand what is it that they're talking about, and is this interesting, and could I apply it in my life.
So Mike, you're my favorite pessimist. So on the Kickstarter campaign, what sort of questions do you think we're going to see?
Why do I need this? You know, that's the general question is going to be, why do I need this and how does it benefit me? Because, you know, there's already hot water heaters, there's already PCs that are out there. There's things that are out there in the market that are already doing the things that we're going to do.
10 years ago, why did we need one of these? We didn't need one of these. Nobody had even conceived of one of these, right? You had a cell phone, it did one thing, it made calls. And then it started to make texts. And then somebody had a web browser. And then the next thing you know, it's a calculator, it's a computer. Actually, it's far more powerful than the first computer I ever built. You guys saw that thing, 386, give me a break. This thing is amazing compared to that. Why do we need it? We don't need it. How many of these sell? Billions? I don't have any idea. But there is a need for this. There's a need for the technology. People don't recognize the need yet, but they didn't recognize they needed one of these either because they'd never seen one. They never thought about it. They'd never conceptualized that you could actually do the things that you can do with this now, right? So there's a good possibility that people in second, third world countries will never have a computer because they don't need a computer. They need one of these. They need an interface.
If I really want to be serious and evaluate what is the return on investment, is that, you know, drawing that picture, because it's complicated. So if I use less energy in 500 different homes, what is the benefit of that? Well, maybe they have a lower energy bill, but also, you know, as that ramps up, as there's more and more of that, maybe we don't have to build another coal-fired power plant or a gas power plant or a nuclear power plant. Maybe we can sustain a few more years using what we have by reducing our consumption.
So the thing that keeps me going is the people who say it can't be done. The more they tell me it can't be done, the more I intend to do it. I know it can be done. When I talk to engineers, and we spend 10 minutes talking about all the potential behind it. It takes a while, but all of a sudden the light goes on and they go, of course, why are we doing this? Why are we doing this today? I think that's a bit of the crusade that I really enjoy, getting people to think differently. So with the next prototypes, we'll be able to prove that it is viable to actually distribute this computation, to put the heat where we need it, to offset the load, existing loads in buildings, to offset the heat that you need to wash your clothes, to keep your kids warm, to cool the house in the summertime. All of those things we can do. We can do them today. We need to build the prototypes to show that we can do them today. We need to go hotter, we need to go harder, and we need to build faster.